Okay, so let's introduce the same concept that Kai was describing as value sets, but from the SNOMED side. Sometimes we use the same word in different ways or different words to represent the same thing. Yes, that's the problems of language usually. So what is a subset? And we will see the relationship between subsets and value sets and subsets and ref sets. Yes. So a subset is a group of things that belongs to a larger group. Yes. So that small circle in the middle of the large circle is a subset. This is a subset of the circle. This is the meaning of the word subset in the most pure way, in the most linguistic and natural way, not related to terminology or to SNOMED. And when we're discussing terminology, a subset is a list of concepts. From a large set of concepts, you select a few of them, and that's a subset. What, what Kai has been showing you using the value set expand operation is how you can retrieve a subset using FIRE. So a view of a subset from the FIRE standpoint using a FIRE API is called value set. Yes, so value set is a FIRE resource, is a FIRE structure that represents a subset, and the subset is in the underlying thing. It's the fact that it's actually just a set of concepts selected from a larger list. Yes, and there are some ways in which you can define the subset. One way to define a subset is to enumerate the members, is to say, okay, this is a member, this is a member, and this is a member. You pick the three concepts, and that's the list. One by one, you select each one of the members of a subset. This is a typical enumerated or extensional subsets. Yes, extensional means like an extensional logical definition. But there are other ways to create subsets, and maybe Kai showed that a bit, which is you can do a query to define a subset. Yes, you can filter automatically, filter the content with some pattern, and the ones that match that pattern will be the members of the subset. Yes, so you can say, for example, all surgical procedures are a subset, and you use an ECL query that says descendants of procedure in SNOMED, all of these, or descendants of surgical procedure, and all of these will be part of the subset. Or you can say all the filter they apply to the subset are all the disorders with a morphology of inflammation. Yes, and this is how you create. So we say that the subset and value set is the same, but the view subset is like the pure thing, that's a subset of concepts. And the value set is a FIRE resource. It's how you see a subset through a FIRE API. And we have two types of subsets, subsets that are pre-prepared for you as a list and subsets that are the result of a query. If you compare both, you can realize what's the advantages and disadvantages of each. Yes, it's the manual subset, the list, is really easy to create, and you have a lot of power to say what's in the subset or what's not in the subset. You see each one of the concepts and validate each one of the concepts. So for small subsets, doing it one by one, it's the right way to go. But when you need large subsets, like all such surgical procedures, it's impossible to do one by one because there are thousands of concepts in that subset probably. So you need to use some kind of query. Also, one advantage of using a query is that if I do a subset manually and as SNOMED evolves and in the new release, a new concept is created, that concept will not be part of my manual subset. I need to look at the new concepts, see if the new concepts are relevant for my subset, and adding them one by one into the subset. But instead, if I have a query and I say all kinds of surgical procedures or all disorders with inflammation, if a new concept that matches the filter, the surgical procedure, or if a new concept that matches the disorder with inflammation is created, in a new release, when I execute the query again, when I execute the filter again, this new concept will automatically be part of the subset. Yes, that's the advantage of using a query. It's updated automatically with each SNOMED release, and the normal ones, the ones that you select one by one, are not updated one by one. Yes, so we create this subset because it's a very useful way to customize SNOMED. SNOMED is a large terminology, and when we implement and when we apply SNOMED to different use cases, we sometimes we say, okay, I will use this part of SNOMED for this particular use case. Yes. So many times these subsets are exposed in an application to the doctor, yes, or are exposed in a national implementation guide to say these are the allowed values for this field and things like that. So this is really important. So because subsets, what they do is they ensure that the SNOMED is used in a very consistent way and is constrained in the way that you need, because it's a, if I have a diagnosis field, I don't want people to submit a procedure in the diagnosis field or a medication or the name of an organism. So in order to ensure that, you say this field will be restricted by a subset, an intentional subset with a query or an extensional subset with a list, so I can ensure that the right information will be there in the right place. So let's look at some examples of how we use subsets in SNOMED implementations. Yes. Constraining search and data entry, and this is a typical one I was mentioning. So if you are typing in a field for a diagnosis and you write append, yes, that will automatically bring appendicitis because that's the diagnosis. But if you are filtering in a procedure field and you type the same letters, append, it will bring you appendectomy, for example. And because it's a procedure field, and appendectomy is the shortest and more similar procedure, yes. Other option is is to clarify communication. When we define electronic documents that will be shared between systems that will be used for reporting or that you can use for decision support, you may want to use this. For example, let's say, let's agree on a file structure for an encounter. On the encounter, we have a diagnosis, and the diagnosis of the encounter will contain SNOMED CT code, but not any SNOMED CT code. It will contain SNOMED CT code that is included in this subset, either with a query or with a list. Usually, for a field like diagnosis, it's always a query, an intentional ref set. But if you are describing gender or if you are describing some shorter list of values, maybe you have an extensional ref set and a manual list of things to add. And also the subsets are really important when you are working with data analytics and data retrieval, because that's how you start your analytics process. Yes, you say, okay, I want to find all patients are diabetic. So the first thing you need to do is to go to SNOMED and find all the codes for diabetes in SNOMED, either with a query or either with with an extensional definition, picking concepts one by one. Once you have the list of codes that are relevant for the query that for the analytics task that you need to do, then you go to finding the actual clinical record, which patients have been coded using those codes. Yeah, so you start actually with a subset for all your data retrieval and analytic tasks. Yes. So how can we represent this? Yes, in a SNOMED. Yes. So we say that a subset is the abstract idea of selecting a few elements from a larger set, and a value set is how you see it on fire. But how is this represented in the SNOMED release? How is this represented in a SNOMED? So one simple way to represent a subset is to assign an identifier to a subset and a name. So this is a very comfortable way to share this with other people. So I create a subset either by query or either by manually, and then I assign a name to the subset. This is the like notifiable mandatory notification diseases in France, something like that. And you create a name for the subset and you assign a code to a subset. In SNOMED, you can do that by creating a concept, yes? And the subsets with the code and with the name in the SNOMED structure, I'll call reference sets, yes? And we will see the reference set is a dynamic structure that is present in the SNOMED release that allows you to represent subsets and many more things. You will see that maps are represented as reference sets as well, and the language preference and associations, historical relationships. There are many applications for reference sets, but the most basic application for a reference set the one that doesn't add any information to any member, is the creation of a subset. Yes, and this allows you to have a ref set ID, which is a concept ID. It refers to an actual concept, and you can add descriptions and even synonyms to the ref set describing how it's used. This new concept that you created, the terminology, it's in a part of the terminology, which is the metadata hierarchy. So this concept is not a diagnosis concept or a procedure concept or an anatomy concept. It's a technical concept that is in a part of SNOMED that is called the metadata hierarchy. Yes. So the parent
Alejandro,
of, yeah,
hey, could you show us the browser and
yeah,
look up the simple type reference set, and let's have a look at the descendants.
yeah,
That'd be
let's do
interesting.
that.
Thank you.
I'll do it in, I'm thinking if I can do it in French, but I'll do it in English. So I'm more sure. So this is a SNOMED, right? I can search and look for anything here. But if I go to the root concept,
Can you
SNOMED
can you
CT
zoom in,
concept.
please?
Oh, yes.
You're showing off how
Yeah,
high resolution your monitor is, but
yeah, it's easy with the large things in front of you, but not
bit more. Well,
more.
yeah, great. Thank you. Yeah, great.
That looks good. Okay. So these are the main hierarchies in SNOMED. We have clinical findings, we have procedures, we have the pharmaceutical products, organisms. I know you will be using organisms, for example, in France a lot. So these are all the different hierarchies. And there is one of them, which is the SNOMED CT model component metadata hierarchy, this one here. So if you go in here, these are not clinical concepts. These are concepts that are, these are the concepts that define the building blocks of SNOMED. Defines the attributes and the properties and everything that is done in SNOMED, the types of relationships, a lot of things. Yes, most of them, the core ones are the ones that define that. So the values in each one of the fields of SNOMED, the acceptabilities, the preferences, all that. But in the foundation metadata hierarchy, yes, this is the one that contains all the extension mechanisms and the reference set concepts. So this code here, and this is another one example of why we need to use subsets, yes, because SNOMED is such a big mix of things. So it's a large ontology that contains concepts from all different aspects of healthcare, but it also contains clinical concepts. And you can see how all these things should not be available for coding. So you cannot have like a diagnosis field and someone creates enter a concept that is called reference set foundation metadata concept. This has no nonsense in clinical. And that's why every time you implement SNOMED, you restrict, you constrain the terminology in some way. And that's how you use ref sets to do that. If you want to save a ref set with a name and an ID, you put it inside here, below one of the ref set types. Yes. So if we look all of them, yes, we should have one for simple type reference set, which is map to SNOMED. These are all the uses: order association, simple map, simple map, simple map. I don't. Oh, simple type. That's the last one. This one is a simple type reference set, and this is a subset. Yes, the concepts that are below here are actually subsets. Then we have the dentistry reference set. We have the general, the odontogram or the periodontal reference set. We have the general practice reference set, the global patient set, the laterality indicator, lateralizable body structure, and all that. All these are reference sets. If I select one of these, it's like, for example, the odontogram reference set, I should be able to see the list of members. I'm not sure if this is loaded here, but just, yeah, it is. So I can see that all these is a odontogram reference. There are 121 concepts that were manually selected. In this case, it's small, but they created a ref set with all the different teeth, all the different finding in the teeth, and all the different procedures that can be recorded in an odontogram. So if I go to the summary, this is a concept, has a concept ID, and it contains all these 129 members. Yes. So this is how it's the ref set is represented in the SNOMED release and is part of the package. When countries start working, creating their SNOMED extensions, they actually create the reference sets that are required on their countries. Yes. So a part of one of the first things that countries do is to define a few reference sets. They assign a name, they assign an ID, and they share that with their users. And usually they are linked to specific use cases, like the vaccines that are available in a country, the different types of genders that are used in the clinical record, the list of specialist names like occupations, cardiology or pulmonology, all those things that are agreed nationally. So it's very common that countries start to create that. And when you want to share the subset with someone else, one way to do it is to create a concept and define that as a simple type reference set, or to include it in your national extension. When we zoom into the language in the simple type reference set, we can see we have seen a bit of this structure before. This is like the RF2 structure. All SNOMED files have these columns, yes? ID, effective time, active, and model. This is like the basic structure of the SNOMED CT RF2 representation. But in the refset type file, you will see two columns. One is the refset ID that points to the concept that identifies the refset, the one that we are just seeing in the hierarchy. And the other one is called referenced component ID with the refset member. And we use that word, we say we have refset and we have refset members. Yes, and the members are each one of the elements inside the refset. Yes. And this is a simple type reference set because it only contains the reference to the member and anything else. When we go to see maps, we will see that it's very similar. The refset ID is a concept for the map refset. The referenced component ID is the concept that we are mapping, and then we add a few columns like the target ID, source ID, or any other that adds additional information to the refset. So in this case, this is called simple because it only contains the reference to the member and nothing else. Yes. The concept, in this case, the concept will always be a descendant of simple type reference set, like we saw there. We looked at there was like a grouper for the dentistry refsets and then the odontogram refset. So they may not be like a direct subtype of the simple type reference set concept, but they're always inside that small hierarchy. And this is the member. Yeah. This column links to the member of the refset. So let's say I have a subset, and a subset can live in Excel, for example. You can create a subset in Excel by selecting 3 codes, and that's a subset. It's not shareable, something that you have in your file. You can put it in a database, you can use it, but it's difficult to share because you need to agree on which columns you will use and things like that. If you want to have a standard representation, you migrate to a reference set, yes? And the reference set is more detailed. You have an ID for each row and the columns that we just discussed. Effective time, active model ID. Those are the first 4 are the standard RF2 in SNOMED. Columns, yes, effective time is the time this row was added. Active means that the row is active, and model ID is to which extension this structure belongs. And then you have the refset ID that will be identical for all the 3 of them because it's a single refset. And then you have the referenced component ID, the actual member codes in a separate column. Yes. So you can see how what you have in the Excel spreadsheet maps directly to the content of the refset, but the refset adds additional information in order to be able to version that property. And that the refset ID is always, for example, in this case, infectious disease simple reference set. Yes, this kind of code, which is a fake code, is always some kind connected to simple type reference set. Yes. So let me show you how to create refsets. Yes, and this is a tool which is called the reference set and translation service, a tool that the SNOMED provides for free to SNOMED users. You can apply to use this tool. And
Can
this
you zoom
tool
in a
allows
little bit?
Yeah, you're right.
I know I don't want to lose columns, but just a little bit.
Let's see how much we can go. I think it can do a bit more. Yeah, it's fine.
That's okay.
Yeah.
Yeah, thank you.
Yeah, it adapts nicely. Okay, so I will move to an author role there. Exactly. These are all reference sets, yes, or subsets that we can create. This is a new word, which is local set, which is to try to confuse you, but they're all subsets. And when you create a ref set in the tool, it assigns a concept ID. When you create a local set, it still doesn't have a concept ID. That's the difference. It's more similar to a subset. So I'll show you how we can create one. So let's say I do local set, I can leave that blank and I say test subset France onboarding. Yes, we can see we will use the SNOMED CT and the latest version. You can check that everything works fine. And then we see that here have the two options. If it's intentional or extensional. External is another option, but it's not the typical ones. So we'll first create this rested one by one. The description, and I add it. And I just created the subset from onboarding. It's here, yes, in the middle of the screen. So now I can go and start adding members. And this is compared to an Excel spreadsheet. This is better because it will help me. I need to assign it to myself. I'm going to assign it to edit to myself. There, good. And then assigned, I have the France ref set here. If I do it in Excel, I need to copy and paste the IDs. I can mix up, I can make an error, I can, maybe IDs are rounded sometimes in Excel if the IDs are too large. So there are a lot of drawbacks on maintaining ref set in a spreadsheet. So this is a more professional way to maintain small subset. And also, when you update the terminology to a new release, you will get notifications when the concepts are inactive and things like that. So if you want to add something here, you can click add member and you look for asthma. Yes. And you can search and you say, okay, I will add the concept, the family history of asthma. I want to add that one. And you click there and now it's a member. Yes, so that means that the concept has been added. And when I go to asthma and I say, okay, I can add asthma itself, or maybe I can add the children or something like that. So if I click on this side, I click on asthma, I have these options to say, okay, you want to add only the concept asthma or asthma and all the descendants. And even when I'm using this like a query, I'm using this as a shortcut to add many concepts at once, but this is still a fixed list. So I can do like add all of these, takes a bit more, and we have 110 concepts. I have family history of asthma, and I have all the descendants of asthma here. And then I can look around and say, okay, I don't want this one. I don't like it. So I have 109, and I don't want this one. I have 108. And this is how you create a small ref set. It's not really hard, yes, and you can do it one by one, or you can use the hierarchy to leverage that. Yes, and the other option is to use an extension of ref set. I don't know if we have time, but if we do that, instead of selecting the concept one by one, you enter an ECL query, you click and the query is executed and you get all the results automatically. And you don't go and select and choose one by one. You just trust in the query. And if you don't like the results, you modify the query to make it smaller or larger.
All right. So Alejandro demonstrated how you could create subsets using some free open access tooling from SNOMED International. You don't necessarily have to publish your subsets using RF2 and a SNOMED extension. You could create them directly as a FHIR value set. But even so, I think it's good to maintain them in SNOMED-based tooling because it can help you with the maintenance of the reference set. Okay, we're going to continue with looking at the FHIR API for about 15 minutes. So subsets really mean value sets in FHIR. Alejandro's talked about some of the different use cases for value sets, the different ways they can be created, some options for maintaining them. And I'm going to look at the different ways they can be accessed once they're in a terminology server. So there's a couple of ways you can publish a value set. it could be published as a Fire value set in the Fire native format. And in that case, you may give your value set a URI that probably contains the domain name of your organization and maybe some name, and then you can just refer to the value set using that URI. If you publish your subset as a SNOMED simple reference set, then in a terminology server, you would access it in this way. You would say SNOMED.info set some module of your extension, and then we've got fire_vs ref set, and then the identifier of the reference set. And so expanding that would give you all the members of your reference set. So those two are where the reference set actually, sorry, the value set actually exists and have been saved in the terminology server. And then the next two are where the value set doesn't actually exist and it's created at runtime using a query. And there's two types of query. There's the is_a query, which is basically a hierarchy constraint. It gives you a concept and all its descendants. So it's like getting all the concepts that are this type of thing. So it could be asthma, for example. That could be the I don't know what concept identifier that is. But if we say is_a asthma, it would return around 100 concepts, including asthma itself, only the active concepts. So this value set wouldn't need to exist up front. And then we've, of course, got the ECL, the SNOMED query, where we use ECL/ and then some ECL statement. And there's documentation on this. On the HL7 Fire website, there's a section, I'll go and find it, that'll be easier than explaining. On the HL7 Fire website, we have implemented the R4 version of Fire. I know R5 is live now. We may not implement R5, we may jump to 6. But the point I'm trying to make is in this section here against terminologies, there's some terminology specific information here. You can do some filtering on LOINC, for example. And at the top here, we've got SNOMED. And this lists all the SNOMED specific things you can do in the Fire API commonly, the different types of filters. It talks about using expression constraints inside a value set. But I am talking about implicit value sets where you do this, Fire VS, and some type of ECL. It's very small, sorry. Okay, so it is all part of the standard. It's not something that SNOMED International made up. Okay, so we can all, with the terminology server, we can also search within a ref set or a value set. Let's try this one. We're going to expand one that's been published as a SNOMED simple reference set. It's the International Patient Summary. It's a set of license-free SNOMED codes. So I've used Fire VS ref set and then the reference set identifier, and I can use the filter parameter as we did before. So I'm searching here for swell, and I've found swelling, lip swelling, joint swelling, many types of swelling. So the Fire terminology services, of course, support searching in reference sets. Alejandro has already shown this in the browser where the simple type reference sets are listed under the simple type reference set concept. And different editions of SNOMED publish different reference sets. And here's an example of the ECL query. So let's run this one and I'll paste the example in the chat. Where am I going? I have to expand. So this is probably the most common, or one of the most common use cases. Oh dear, what have I done? Something. Didn't pre-prepare this URL. Okay, so we're searching within inflammatory disorders, and I'm filtering by ear. Oh, I'll paste this example somewhere. There it is. Okay. All right, this is worth mentioning. So best practice search behavior. This is really important. Some of the SNOMED concepts have got very long names, and we know that clinicians aren't, they're obviously always pushed for time. Not all of them can spell perfectly, and they want to quickly find what they're looking for. So a good technique for search is to use multiple prefixes. So for example, if a clinician is trying to find this concept, blood oxygen pressure within reference range, a good search term might be blood ox within. And your search algorithm or your terminology server, however you do it, if it enables this type of search, then the clinicians are doing less typing, there's less risk of spelling mistakes, and they're finding, what they want faster. So in the terminology servers we demonstrated today, they both implement this this search type or the search method. We've got about 5 minutes left. I'm just going to touch very briefly on maps and how they're used in FHIR, and then after the break, Alejandro is going to talk more about maps and also how they can be maintained. So obviously maps are a way that SNOMED and other terminologies and classifications can link to each other. So perhaps, a common use case is if you have local codes and you want to migrate to SNOMED, you may create a map from your local codes to SNOMED CT to, support the transition period. Another use case is to have a library of clinical phrases that are kind of an interface terminology that could link to SNOMED. We usually advise against that use case. I might remove that from the slides. The communication of clinical data between two different organizations that use different code systems, of course, you need to use a map. Another really common use case is mapping from SNOMED CT to a statistical classification, for example, ICD-10 or ICD-11, which is often used for some types of national statistics, and it's very commonly used as billing codes. So every version of the international edition of SNOMED that's published every month, has an up-to-date map to ICD-10. Here's an example of what RF2 map reference set looks like. I've put ... here because there's some common fields that are always in SNOMED files that Alejandro showed. It's like the ID, the active flag, the effective time, and the module. But then the other columns we've got for a simple type map are the reference set ID, that's like the identifier for the map, the SNOMED concept, and the other concept. So this one says map target, so we know that the map is from SNOMED to some other code system. This one's ICDO. We've got the ICDO codes here. There are other types of map. Our SNOMED to ICD-10 map is an extended map, and that means as well as mapping the SNOMED code and the ICD-10 code, we also have another column which contains the rules for the mapping, because it's not possible in all cases. There's about 10% of cases where the SNOMED code isn't enough to map to the ICD-10 code, because the ICD-10 code contains more context or kind of combining information. For example, in SNOMED, we have a concept infertile, and it's not gender specific. Whereas in ICD-10, the fertility concept is gender specific. So you need that extra piece of information, the gender, to be able to do the mapping. So in an extended map, there's some computable rules where you can choose, if it's male or if it's female, it's this code. And there's only 2 items that are needed to implement all these rules. It's the gender of the patient and the age of the patient. And then you can do the complete mapping. We've got demonstrators for that if you'd like them, because you need some regex to implement that fully. And my last slide, in Fire, this is how you call how you use a mapping. So you use the concept map, resource or course, and the translate operation. And we give a code, source system, which in this case is SNOMED. Here I'm also giving a version. I'm saying I want to map from this edition of SNOMED CT. And then I'm just giving a target system of ICD-10. You'll notice here that I'm not giving it a specific map to use. I could give it a specific map, but here I'm just telling the terminology server that I want to map between these 2 code systems. You do the work. This is how Snowstorm implements it. And this is the response. So we have, what always confuses me is it doesn't display the source concept, but we've got the SNOMED concept is up here, and we've got a list of mappings. So this one maps to ICD-10, and it's this ICD-10 code. If we had loaded the ICD-10 code system into SNOMED CT, we'd also get the display, the ICD term for this concept. And here we've got the map advice. In this case, it's always to this code. There's other examples where it may be different codes depending on the gender.